Assalamu alaikum dear students. Today we are going to discuss in the graphs of trigonometric functions. You know there are six trigonometric functions, basic six trigonometric functions: sine function, cos, tan, cosec, sec, and cot. Now firstly we will discuss the graph of a sine and cos function. Since you know that the sine and cos functions are defined at each and every real number. So this means that when they are defined at each and every real number, hence the domain of such functions means sine function and the cos function is set R. Domain means where this function is defined. So the domain of both these two functions is set R. So this means that if we consider a function from f from R to R, defined by f of x equals to sine x or f of x equals to cos x, this means that the domain of these two functions is set R, because these two functions are defined at each and every point of this first R, means R. Now we will draw the graph of these two functions. Firstly, consider sine function. Now how to draw the graph? We will consider the two axes, one the x-axis, which is the domain axis, and second one y-axis, which is perpendicular to this x-axis, and this is the codomain axis. Now the point where these two lines intersect is simply 0. Here this x-axis means points x, so we have to consider x from this R, and this is f of x means corresponding range elements. So this is y, this is simply y. Now we will tabulate the value of some standard points at, like, if we consider x in the first row and f of x corresponding value of this x, or the value of the function at this particular point x is f of x, which is sine x. Now at 0, we know that at x equals to 0, when x is 0, value of the sine is simply 0, because sine 0 is 0. So this means that when x is 0, y is 0. So x 0, y 0 means we have to locate this point origin. So we will highlight this point like this. Similarly, at when angle, or when the value of x is pi by 4 means 45 degree, and at 45 degree the value of this function, this sine function or f sine of pi by 4 is 1 by root 2. You know that the 1 by root 2, the value of this is less than 1. It is less than 1. So less than 1 means, like here, when x is pi by 4, the value of this f of x is 1 by root 2. So the point is this, because the value of 1 by root 2 is less than 1. Here it is 1, so the value is here 1 by root 2. Similarly, when we consider 90 means pi by 2, is greater than pi by 4, because pi by 4 is 45 degree and this pi by 2 is 90 degree. So this means that the point which is greater than another point, we have to represent it right on the real line. So this means that we are representing pi by 2 here, because it is greater than pi by 4. And at pi by 4, the value of the sine function, or the value of the sine, is 1. So at pi by 2, value is 1. Here we have 1 means y, and we will join this. So the point here, it is pi by 2 1, because x is pi by 2, y is 1. Similarly, we can have this the value of this function at pi. Value is 0, because sine pi is 0, so this means that it is this. Similarly, at minus pi by 2, sine of minus theta, you know that from sines of trigonometric functions, the value of sine of minus theta is minus sine theta, which implies that sine of minus pi by 2 is minus sine pi by 2. Sine pi by 2 is 1, so the value is minus 1. So this means that at minus pi by 2, value is this. At sine of minus pi, value is simply 0. So this means that point is this. Now we will consider all such points and join these points because there is connectivity in the domain, because it is defined throughout. So this means that definitely there is connectivity in this, or we will get this pattern. So join these points. When we join these points, the graph obtained is of this form, that is this. Here in the range range set is from -1 to 1, because the value of this from the graph, it does not cross the one from this either side, either from positive side or from negative side, that is -1. So this means that definitely the this range of this sine function is between -1 and 1. So this means that range of this, or the value of this sine x, is always from -1 to 1 interval, closed interval means we have to consider the end points also for all x, means x belongs to R. Hence the value of this sine x is always greater or equals to -1 and less or equals to 1. So this is the graph of this sine function. Also from the graph, the points where the graph touches the x-axis are 0, because here at this 0, at x equals to pi, at x equals to minus pi. Similarly we will have this point minus 2 pi, 3 pi, 4 pi. So this means that everywhere we have the integral value. So this means that the zeros of this sine function, zeros means where the value of the function is 0, is simply n pi, where n belongs to natural, where n belongs to integer. Similarly we can have the graph of this cos function, because in the same way we can draw the graph of this cos function, and we will firstly consider the value of the function, or the value of the cos at some standard points, like at 0, at pi by 2, at pi, at 3 pi by 2. So when we draw the graph looks like this function. It touches the point 1 at x equals to 0 and minus pi at -1. So this means that the graph of this cos function is like this. Here clearly from the graph lies within the point, within -1 and 1. So the value of the cos x is always between -1 and 1 for all x belongs to R. Hence the range of this cos function is closed interval -1 to 1. -1 to 1. Here the zeros of this function, this cos function, means the points at which the graph crosses or touches the x-axis. It is at pi by 2, because here at 3 pi by 2, at minus pi by 2, at minus 3 pi by 2. So it is pi by 2, 3 pi by 2, 5 pi by 2. So everywhere we have the odd multiples, but the integers, odd integers. Hence the zeros are odd multiples of pi by 2, whether positives or negatives, it doesn't matter. Now the another one is the tan function. The tan function, we know that the tan x is defined as sin x upon cos x, sin x upon cos x. Now firstly we will consider the domain. Now this is defined only when the denominator is not equals to 0. Now the denominator equals to 0 is, which means cos x, and we know that the cos x equals to 0 only when x is odd multiple of pi by 2. So odd multiples are pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, or we can simply write this in a general form as 2n plus 1 pi by 2, where n belongs to integer, because 2n plus 1 is always odd, whether positive or negative. So it is simply odd number. So from this tan x equals to sin x upon cos x, when cos x is 0, tan x becomes not defined, or we cannot define tan x in R. So this means that tan x is not defined when cos x is 0. So cos x is 0 at points odd multiples of pi by 2. So this means that we have to remove, or we have to expel these odd points from domain, means from R. So clearly domain now becomes R minus 2n plus 1 pi by 2, because 2n plus 1 pi by 2 are those points where denominator is 0. When we are removing these points from this set R, the new domain becomes R minus 2n plus 1 pi by 2. This R minus 2n plus 1 pi by 2 means we are removing these points from R. So how to draw the graph? We firstly locate these points where this becomes now defined. Now these points are pi by 2 here, then we have 3 pi by 2. Similarly from this side we have 5 pi by 2, 7 pi by 2, so on. And from this left side it is minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, so on and so forth. So at these points the function is not defined, so this means that these are not in the domain. So we are removing this. Removing means we are not considering the value of this function at these points. So let's draw these vertical lines through these points which are perpendicular to the x-axis, or simply the lines parallel to y-axis through these points. At these points the value of the tan is always infinity or minus infinity. Now we will consider graph in this portion in minus pi by 2 from and pi by 2, because function is defined, this tan x is defined at each and every point between minus pi by 2 and pi by 2. Now at 0 tan is 0. At pi by 4 means at 9 in this 45 degree, value of tan is 1. So this means that at pi by 4 value is 1, because this is 1. Now pi by 4 is less than pi by 2, or when we approach this from this side towards pi by 2, the value approaches to infinity. Because at each and every point which are slightly less than this pi by 2, tan is defined. And when we consider, or when we put tan x equals to pi by 2 in tan x, the value becomes infinity. So this means that from infinity means this side. So this means that we are approaching to this side. This arrow indicates here that tan x is not defined at pi by 2. Similarly from this side, from negative side, tan of minus theta is minus tan theta. At pi by 2 value is infinity. So this means that at minus pi by 2 value is minus infinity, and minus infinity is from this side, so it is this. So when we join these points, the graph looks like this, or the graph is of this form. Similarly in this portion, minus 3 pi by 2 and minus pi by 2, the graph is like this. So this means that in every interval between minus pi by 2 and pi by 2, or the interval whose length is pi by 2, simply pi, the graph of this tan function is like this. So this is the graph of this tan function. Clearly the range of this tan is set R, because here this is the range or the codomain axis. If we consider any line perpendicular to this line, the graph touches these lines. So this means that the range is R. When the range is R and the domain is here, R minus 2n plus 1 pi by 2. Also the zeros of this function. Now clearly at x equals to 0, graph crosses the x-axis. At pi, graph crosses the x-axis. At minus pi, graph crosses the x-axis. So this means that the zeros of this tan function are n pi. N pi means pi, 0, minus pi, 2 pi, minus 2 pi, where n is simply integer. So these are the graphs of these three functions. Inshallah, in tomorrow's lecture we will discuss the graphs of other three trigonometric functions. So thank you.